Well, hello there. This is KP, the Math G, ready to work another calculus problem. I said that after we would do trigonometric substitution like we did last time, that we would do some of these free response questions, and so that's where we're at. As you can notice over here in the black, you have a table, all right, and I trust you can see those numbers. I hope you can anyway. And we have f at x, we have f prime at x, g at x, and g prime at x. And then down here in red we have h. Let's see. Well, well, we can say h at x. Okay. H or h at x. It would be better if I put h at x with respect to x there. Alright, h at x then. Okay. And that equals f at g at x minus 6. And I'm trying to make sure I wrote everything down correctly this time. Alright, that is it. Okay. Alright, I wrote everything down. And there it is. Okay, the very first question, and the reason I picked this problem out is that you'll see in just a moment, we refer to things that we probably haven't seen in a little while. So that's why I want to go over this one in particular. I love this problem. I really tell you, I love it. Look at the first question. It says, or the very first problem, it says, explain why there must be an r such that h at r is equal to -5. Well, it would help if we knew where our parameters were. This is 4. Let's try this right here. Let's make sure we understand. This is 4. Let me see here. I just looked at it. Okay, R is between 1 and 3. So what you must do, I mean, intuitively, I would think that if there's an R somewhere in between here, there must be some R. First of all, we do know a couple things, and again, I'm sorry I didn't write everything down, but that one word that comes up in mind, differentiable. Now, what do you know about anything that's differentiable? That's right. It is continuous. Alright. That's the key to knowing that there is an R somewhere between 1 and 3. If this is discontinuous, it may be somewhere discontinuous somewhere in between 1 and 3, and we wouldn't know where, but it'd be discontinuous. But we know it's differentiable, which implies that it is continuous. And somewhere in your explanation you need to say that because h is continuous, okay? So then you got to at least start that h is, or actually f and g for that matter, which is h, is continuous. Then there must be an R. Now we got to find it. So let's see. I want to find h at 1. I know I don't have a lot of room. I may have to flip this board over a little bit. Alright, h at 1 is f at g at 1. Oops. I might get started before too long, y'all. I'm sorry. Alright, f at g at 1 minus 6. Now, g at 1 is 2. Alright, so let me just kind of put a colon here. Alright, so, or a semicolon. Alright, so F then, alright, G at 1 is 2. So F at 2 minus 6. Alright, F at 2. Alright, so F at 2 is 9. Alright, so 9 minus 6 equals 3. Alright, so H at 1 is equal to 3. And that's what I got, yeah, okay. Alright, let me do this again, but this time I'm going to insert the 3 in there. So H at 3, F at G at 3. Alright. Now recall that this is, we're not looking for a derivative of this, we're just plugging the numbers straight in. Okay. Alright. Anybody recall, or can you kind of see where we're leaning towards, or what we're trying to say, explaining why there must be an R somewhere in between here? Yeah. We want to say something toward the end that by the intermediate value theorem, this is true, right? Right, because F and G are continuous, right? F and G are continuous. Alright, because it's differentiable, that's what that implies, right? Okay. Alright, so let's go ahead and see what we get with this one now. F at G at 3. Alright, G at 3 is 4. F at 4 is negative 1. And guess what? That's negative 7. Alright, so H at, let's put it down here. H at 3 is negative 7. So by, so there is an R, alright, such that H at R is between, alright, we know that negative 7 and 3, right? Which, by the way, this was H at 3. This is H at 1. Doesn't matter what order they're in, as long as H at R is between those two. Okay? I know that this says it's, so anyway, we just have that. And H at R is negative 5. And negative 5 then is between, if you want to put that like this. That's perfectly okay. Negative 5 is certainly between these two, right? So that's what we're looking at here. And that is the intermediate value theorem. That's what they were looking for in part A. Okay? That's what they were looking at in part A. Let's go to part B. I don't know if I want to do part C just yet, but let's go ahead and get into part B because it deals with another similar theorem. And now instead of an R, there is a C. Alright, H prime at C. Now H prime at C kind of gives it away to be something else. What theorem is that? That's right, the mean value theorem. So this is why I believe I really like this problem right here. Now, here's what you don't want to do. You don't want to find h prime. Okay? Don't do that. What you want to do is you want to apply that mean value theorem. Now, what does the mean value theorem say? The mean value theorem says that this h prime at c, that the slope of the tangent line is what this is here, which equals -5, by the way. We're hoping that that's equal to the slope of the tangent line, which in this case is h at 3, or it doesn't matter. Well, we could do the h at 1 since, and I just got through erasing those, didn't I? We could do h at 3 minus h at 1 over, let's see what we have, 3 minus 1, right? And that is the slope of the secant line. Remember, the slope of the tangent line is equal to the slope of the secant line. Okay, like that. It doesn't have to be horizontal tangent. It could be anything. But we say if this slope is 0, then this slope is 0 too. This is the secant line, and this is the tangent line. Okay, and that's what we're talking about here. All right, so we're saying that this had better be equal to -5. All right, we know that 3 minus 1 is 2, and then h at 3 is -7, I believe we found that to be. And then h at 1 was 3. All right, and -7 minus 3 is -10, and -10 over 2 is -5, and that's what you want to say. But you want to say then by m, you got to have this in here somewhere in your explanation. H prime at c is equal to h prime at c, all right, is equal to, and then we just found it. You just say that right there, what we just had up here. H at 3 minus h at 1 over 3 minus 1. That assures us that there is a c. And also, again, f and g are continuous. So you want to say that on both answers. Both A and B answers, you got to kind of put in continuity there, otherwise it doesn't mean anything. But that's what differentiable means, is that f and g are, might as well just say h is continuous. All right, continuous, MVT, and this showing that you understood this answer. And that's why I picked this problem mainly. And then there's one more thing that I want to do. I think we have time for one more, and that is, there's only one more. Okay, let's see if I have room here. If not, I may have to flip the board over, and we may just have to flip this board back and forth. Alright, and then do it that way, because I just don't have a lot of room. Alright, I'm going to leave that up there, of course. Oh, I gotta leave that up there. Alright, I think we still need that. Okay, then we might not. No, I don't think we will. Maybe not. Okay, we don't need that, but we do need this. Okay. Oh, there are 4 parts to this. Okay, there is. Now, I think what I'm going to do is do the C part and then do the D part on another video, which I am already itching to do. I was actually looking at D instead of C. So let's go ahead and do C part. It won't take too awfully long to do that. It's very, I think, pretty simple. But now they're saying let W at X. We want to let W of X be equal to, let's see what W at X is equal to. Wow, look at this. This thing is, they've got a 1 down here, and then this is G at X. G at X, L at T dt. Alright. Now they want to find the value of W prime at 3. So that I know that I need to take the derivative of W. Okay? Which means I'm going to take the derivative of this antiderivative. Now, doesn't that point you to another theorem? It sure does. The fundamental theorem of calculus, whether you want to call that part 1 or part 2, depending on the writer of the book. There are two fundamental theorem two parts to the fundamental theorem of the calculus. This taking the derivative of the antiderivative is one of those. Now, if I go with this and I say, well, this is W prime, and I'm going to make all of this prime. I'm going to prime that. Well, what's that? Well, it is, you just simply just say, instead of, we say F at G at X. Now, don't leave it like that. That's not all. And I thought about this, and I thought, well, I got to take the derivative inside here, kind of like the chain rule. Now, if you leave this off, you're really just got this first part right here without the -6 there. Okay, now that's what we're dealing with right here. Now I can deal with W prime at 3, which equals F at G at 3 times G prime at 3. All right. I knew this would be, you would like this, but I love every part of this problem. And if you get even just those parts right there, I'm trying to see what the point, okay, that would be 6 points, and then D part would be 3, which would give you a full 9 points to it. Okay, which we'll do D part in another video, but I need to reserve that. I need that time. Okay, this is good enough. I know what G prime at 3, or G at 3 is. There's 3. G at 3 is 4. So we're looking at F at 4. That's what G at 3 is. Now G prime at 3, let's get that answer. G prime at 3 is 2. Alright, so F at 4 times 2. Alright, G prime at 3 is 2. Alright. Now F at 4. F at 4. Alright, so F at 4 is -1. So this is -1 times 2, which is -2. Alright, that's it. And I'm just going to let that be. We did 3 parts to that, and I kind of took my time with it. I wanted you to understand what we were doing. So in review, we did IVT, and then we did MVT, and then we did the fundamental theorem of the calculus. And if you've already looked at this, 2007, you already see where we're going to talk about inverse, and that has a rule to itself also. Alright, anyway, this is what we have. I'm going to leave this up here for this table. I'm not going to erase this table. I don't want to have to rewrite it. But anyway, I hope this has helped out, and this has kind of jogged your memory for the upcoming test that you're going to take. I don't know when you're taking it. End of April, early May. I don't know when y'all take them now. But anyway, and in calculus, you know, you got your end of semester, so you got that to look forward to. Anyway, this is KP the Math G signing off. Please subscribe if you haven't done so already. Do that, and please, if you would like to hit that like button, that would be nice too. And if you'd like to make a comment, that would be all right too. Sorry about the 2 or 3 day delay, actually 2 days. We've been busy trying to get a riding lawnmower with new blades on it, and then just a push lawnmower with a new blade on it. You do not want to see the blades at all. They are dull from last year. We have a lot of rocks in our yard, and so we have to be careful. Try to not hit rocks, but I'm going to hit a rock even this summer, I know. But and we're getting gardens and a couple of greenhouses set up and going, and I got one going now. So anyway, that's where my busy work has been. And then I said, well, I told my wife I'm going to do a video, and so anyway, KP the Math G signing off. Have a great day.